Yeah, so I was told the session will be about big data and small data, so I will mostly be taking the big data part of that topic. And I want to frame the stuff that I'll tell you about today within the context of sociolinguistics, especially big data for sociolinguistics. These are sort of really traditional questions that sociolinguists have been interested in for many decades. How does language vary across different groups of people, whether those are geographical groups or social groups? How does language change over time? How are language differences evaluated socially? So these are all questions that I'm interested in thinking about ways to use large-scale social media data to answer. And to really motivate that, I wanted to talk a little bit about sort of the real, I think, like most classic traditional sociolinguistic study. But I wonder, because I don't totally know the audience, like how many people have know about this study already? So, okay, so like less than half. Okay, good. So I don't feel bad talking about it too much then. So again, this is like a really classic study, and this was something that kind of one of the founders of modern quantitative sociolinguistics did in the 60s in New York. And so the study is about this specific sociophonetic variable with the way the R is pronounced. I'm not going to try to pronounce it. It's something specific to New York English, and you know, my accent has maybe 10% of that or something, so I don't know. But if you say fourth floor, there are different ways that you can say this, and this is sort of what the researcher was trying to get at. And he had this intuition that that this linguistic variable, in addition to indexing New York City as a geographical region, also had some kind of socioeconomic association with it as well. And to test this idea, he went to 3 different department stores which were organized in sort of a socioeconomic hierarchy or class hierarchy. So there was a store called Klein's at the lower end of the spectrum, Macy's in the middle, and Saks at the high end of the spectrum. And what he would do is in each of these stores, he would go in and he would ask a question to a clerk where he knew that the answer was going to be fourth floor, so where are the ties or something. And he would pretend not to have understood the clerk, and then he would get the clerk to say it a second time. And so this kind of enabled him to test a bunch of things at once in an interaction that might only take 30 seconds. And so that was what was so sort of brilliant, or one of the things that was sort of so brilliant about the study. So, you know, what he found was that there was this kind of interesting intersection. So this is, again, this is a New York variable. The pronunciation that he was looking for was a so-called R-list pronunciation of fourth floor. And so what the figure shows is that, so the figure shows the percentage of time where people use the standard version of this variable, so the version that you would hear throughout most of the United States. And so in the lowest socioeconomic status department store, that was very rare, but it was increasing over the course of the interaction. So the first time they say fourth floor, they almost never use the standard R. By the second time, they're using it maybe twice as often. But that not nearly as frequent as you see in the middle class and in the upper class oriented department stores. But also in those stores, you see this increase over the trajectory of the interaction as well, where by the time they get to the final R in floor, they're using the standard form more than half the time. So what I think is one of the things I think is so great about the study is that in this one 30-second interaction, he ties together geographical variation, socioeconomic variation, and then what I would call stylistic variation, which you differentiate from the first response that the clerk gives, fourth floor, and then the second response is maybe stylistically different because they understood that they had to give the information again. Okay, but like what made it possible to do this study? And I would call this sort of a needle in a haystack kind of study, right? Like he had to find this variable R that is so ubiquitous that in a single interaction you can get 4 instances of the same variable. Again, in under 30 seconds. Also highly differentiated, so something that you would immediately associate with both New York English and also expect to have a strong sort of socioeconomic orientation as well. And I think this just requires kind of an amazing amount of intuition on the part of the researcher to identify a variable and design an experimental protocol that could elicit this kind of data so that this research could be carried out by one person in this way. And so, I think a question you can ask is, like this is fantastic, but we can learn things about New York English because Labov was from the New York area and he had these intuitions. But like, what are we missing if we sort of require this sort of heroic level of effort or level of intuition from researchers. So this to me is a little bit of a motivation for thinking about other methods as well. So I'm going to talk now mostly about my own work in terms of using large-scale social media data to try to ask similar sorts of questions. And so I'll focus, I think, one of the real powerful things about large-scale data is that it allows you to focus on what I call rare events, so variables that are much, much, much less common than the phoneme R. And then I want to talk a little bit about the sort of annotation issues that come with thinking about large-scale data. Okay, so of course R you're going to see in maybe every third word or something in English. When I started doing this research, I was living in Pittsburgh, and so naturally, the first thing I was wondering about was the second-person pronoun yins that they have in Western Pennsylvania. And so as soon as I got a large-scale Twitter archive where I had geographical location for the tweets, I went to look for this word. And you do indeed find it in Western Pennsylvania, but it is super rare, right? So in a data set of 1 million tweets, you'll find it on average 3 times. So you really need hundreds of millions of tweets to really get any reasonable sample to say anything about a variable like this. And so that's something that you can really only look at least if you're going to look at sort of tweets throughout the United States. You're going to need quite a lot to get sort of significant evidence of a word like this. Another thing maybe more relevant to where I live now, this is a slide from Jack Grieve, is this so-called double modal might could. So this is something people do say in the southeastern United States when they want to indicate sort of real uncertainty about something. And again, sort of according to Jack's slide, this is something that you see even in the places where it is most commonly used. You see it once every 1 million words. Yeah.
So that's only the ones that were geolocated?
Yeah. So per 1 million geolocated tweets, I should say. Yeah. And yeah, you can ask what's sort of different about geolocated tweets from other tweets. I think that's a good thing to ask. We could talk about that. We have a little bit of evidence on that, but it certainly is a different set. It's a different type of person. Okay, so for might could, and again, this slide I think is broken down by county, which is sort of a US geopolitical kind of unit. Even in the counties where it's sort of most commonly used, it's only once per 1 million words. So maybe on order of 10 per million tweets. Okay, so you can look for variables you already know about, like might, could, and yins, but another thing that you can get from big data is that you can try to discover new variables automatically. So you can use a statistical approach to say, are there features that are really especially common in one region and uncommon in another region? And I won't talk about the sort of math behind how to do it. So the first thing that we did was look specifically at metropolitan areas and do sort of statistical tests to look for things that differentiate those areas. Actually, Dong and I had a paper this year on a non-parametric approach so that you don't have to break up the world into metropolitan areas. You can just work directly on latitude, longitude data. And that sort of, I didn't get a chance to put a picture from that in here, but that allows you to look for words on a much more local level. So even within a city, are there geographical features that have, are there linguistic features that have a very strong geographical orientation within a city? So we've looked at Paris, for example, and found different slang words that are used in different neighborhoods and stuff like that. So you can, with large-scale data, you can start to do these sorts of things. And for us, really there are things we found this way that we never, I think, would have thought of looking for. So when you think of an abbreviation for a phrase, you maybe think about this as indexing internet language or something about online language or youth language. And so it was really not something we expected to see, that many of these were quite geographically oriented as well. So this is kind of old data now. This is like 2012. So whether this is still associated with Chicago, Illinois, I don't know. But certainly, as time goes by, there continue to be geographical markers like this. So maybe it's a different abbreviation now that has that orientation, but it's still the case. Okay, so that's to talk a little about geography. another thing that we can ask about are social variables, so distinguishing speakers and writers on various social dimensions. And early studies in terms of using social media, at least for language analysis like this, really focused on like big demographic variables, so like race and gender and age, like men are like this and women are like that. And that's sort of like a pretty, I think, retrograde way to look at social variation from the perspective of people that are actually doing, sociolinguistics. I think, there a lot of the action is looking at intersections between variables, so sort of intersectional perspectives on social identity, as well as locally defined social categories. And so this is a social network from a single high school in Michigan that Penny Eckert looked at in a sort of a well-known study there, where she was able to identify linguistic variation between these locally defined social groups within the high school, not big demographic categories like men and women, but categories that really only make sense in the context of this high school. So a question is, can big data play a role, in these, I think, some more sort of contemporary approaches to social identity? In terms of intersectionality, I think I was a little nervous to put this slide because there's just like a lot of stuff to take in, but you can indeed sort of really start to slice up data or slice up things on a number of different demographic dimensions. So this is, again, Twitter data. We had people from, I'm just showing New York and Dallas, but we looked at all different cities. We then used sort of a machine learning approach to try to make imputations about people's gender and age based in part on their name, and then sort of with a bootstrapping process also in part on their language. So you can get statistics from like Social Security Administration in the U.S. To figure out for a given first name what's the distribution over ages and over genders, and then I'll talk a little bit to the sort of more machine learning people in the audience. You can use expectation maximization to basically get a virtuous feedback loop to get sharper and sharper estimates over each person's gender and age based also on their language. But what I think is interesting is you can start to see like what distinguishes people on a bunch of different dimensions here at the same time. So a lot of the things people have been interested in thinking about, can I geolocate somebody's tweet based on their language? And the answer is yes, but the way that you do it actually really depends on age. So for young people, it really does seem to be a lot of these non-standard like abbreviations and spellings and stuff. For older people, it's much more likely to be entity names. And in fact, the easiest people to geolocate from their text are like 40 plus men, like a group I unfortunately joined this past year. But 40 plus men are really easy to geolocate because they talk a lot about sports teams, and so that at least on the metropolitan level, that makes them pretty easy to find. So that's sort of an intersectional perspective. In terms of these locally defined social categories, again, going to think about this in terms of unsupervised learning, and this is unsupervised machine learning. And so this is, what we did here is really like the simplest thing you could possibly do. We took a bunch of people's Twitter timelines, and we used an unsupervised clustering algorithm. If you know like k-means clustering, that is basically what we did. We were interested in gender, but we wanted to say, let's forget about gender and let's just look at clusters, and then let's just see how gender shakes out. And what we found is that if you just get 20 clusters of people purely based on the text, so no metadata information at all, purely based on the text. In fact, many of these clusters, most of these clusters, are strongly associated with one gender or another. And again, this is imputed based on first names. So this is, I think, the cluster that was most strongly associated with women on top, the cluster that was most strongly associated with men on the bottom. So you can start to ask these questions. We have these sort of hypotheses, again, very broad sort of hypotheses about gender as a social category. Oh, women use more standard language. Oh, men's writing is more informational. You can then ask these questions, how do these things hold up when I look just at these clusters in terms of something that emerged just from the data as text? And in some sense, you see some confirmation maybe of where you started, like, okay, people hypothesize women use more standard language, and yeah, like the top cluster for women is mostly standard words, not the first word, but mostly standard words. But it's not hard to find clusters that point in exactly the opposite direction. So they're sort of locally defined groups, locally defined units, where it is mostly women, and yet like it sort of violates this high-level rule, as I think is not super surprising. Okay, so I want to move now to talk about language change. And this is something where, I think is really quite difficult to study. So the traditional view on language change in sociolinguistics uses a concept called apparent time. So you measure change essentially by looking at differences between young people and old people, with the idea that the language of old peoples is sort of formed in their youth, and so therefore they're sort of like maybe like a living fossilized version of the language that was around at the time that they were learning language. And then you compare that with young people. And of course you have to somehow separate out age grading, which are changes that just happen to all of us through our lives in language. And so, a question is, if we have sort of large-scale longitudinal data over time, does that give us a new perspective on language change? And so, I think in terms of language change, to think about it as like a social behavior that people adopt or choose not to adopt, there's sort of two things that have to happen. So first, you have to be exposed to the innovation that is ongoing, right? So unless you're going to sort of be the originator of this innovation, much more likely you're going to be exposed to it by someone else. And so the structural information that we have about people's social networks that we could potentially get from large social media archives can give us a clue about who's likely to be exposed to what. But then there's an agency question too. So you may be exposed to a lot of things that you don't choose to adopt in your own behavior, or you may be exposed to a lot of linguistic innovations that you choose not to incorporate into your own language. And so that says something, I think, about social evaluation as well. So you're going to be exposed to something, and nonetheless you may socially evaluate it in such a way that it's not something that you want to adopt yourself. So we were interested to try to study this question with Twitter as well. This is sort of the Twitter part of the talk. I'll talk about a different social media data source in a moment. But we were interested to study this with Twitter as well. But there's sort of a problem there. So you can think about this kind of as a murder mystery or something, right? So I have some data, and like person I is all of a sudden they've used this new linguistic feature for the first time. It's at time t. And so who is the culprit? Like, who is responsible for this? Right, so we're looking for some suspect the suspect has to have used it themselves at some t prime before t, right? I can't influence you to use something if you haven't seen me use it, I guess. And J also has to be someone that I is likely to observe, right? So there's the structure of the social network again. So if I don't read your Twitter and I don't sort of have any way to know what you're saying, then of course you can't influence me. But the point is that if this is the sort of event that we're looking for, person J uses the linguistic feature at t prime, and then person I uses it at time t, like what's the likelihood of us actually seeing that if we're working on a data sample? And so this, I think, comes back to this nice talk about Twitter as something that we're sampling from, right? So in fact, that likelihood decreases with like the square of the sampling rate. So if I'm seeing 10% of all tweets, the likelihood of seeing a pair of events like this is 1%, right? And so, in fact, we're seeing probably, we just get the free data at Georgia Tech. I think this is something like 1%, or we estimate this is something like 1%. So the chance of catching, an event like this, or a pair of events like this is basically, basically zero. And so from the free data, it seems like it's pretty much impossible to really catch influence events like this. So our sort of way out of this dilemma basically was to partner up with someone that really had the full data. And so we partnered up with researchers at Microsoft Research, where they have an arrangement with Twitter to get the full data. And sort of working with them, I guess we'll have a panel on like these sort of collaborations later. And so I think the panel's on interdisciplinary collaborations, but actually academia industry collaborations also have some interesting sort of characteristics that maybe we could talk about as well. So I was kind of like, we sort of had many, many meetings, and I was kind of despairing that we would ever really get like any data out of Microsoft in the end, because it's just, there's so many, like once lawyers get involved, you really think your chances are not good. But in the end, like we did get the data. And so, what we're able to get are these records where basically we have different people, and they basically, the condition was that I had to give them like a short list of linguistic features that I wanted data for, and then they would give me data that they didn't give me people's actual names, of course, and they encrypted the user IDs and they encrypted the tweet IDs. They wouldn't even give me the real timestamps because they thought I could somehow reconstruct the data if I knew all the real timestamps. So they coarsened all the timestamps to 5-second. So they're really like very careful about it, because I guess they have a relationship with Twitter that they didn't want to jeopardize. But in the end, we were able to extract data like this that could start to answer these kinds of questions about who sort of influenced who. So we have a social network about who follows who. We have also location information about, at a sort of coarse-grained level, what metropolitan area people live in. And then for these 15 or 20 features that I identified, we know all the times that people use them. And so this is within the set of public tweets. So private tweets we don't have any idea about, but within the set of public tweets we see. So what you can get from this then is that you can then say things like, okay, look, if you're exposed to one of these 15 or 20 variables, how does the likelihood that you use the thing increase? Does the likelihood that you're going to use it increase? This is sort of an epidemic or contagion kind of model of language change. So if you being exposed to this thing doesn't actually increase your likelihood of using it, then the hypothesis that you're somehow, that this language change is happening by influence on the social network, can't be right. Right? I mean, if it doesn't increase your likelihood of using it to be exposed to it, then we're somehow missing the data that we need to be seeing somehow. Maybe in that case, the influence is happening through offline interactions, or it's something that people are getting by watching television, or just something else that's outside of our purview. But that turned out not to be the case. So that would be, for this plot, that would correspond to a relative risk of 1. It's just dividing the likelihood of you using this feature with or without exposure. And we get this kind of interesting thing where for some of the words, multiple exposures really strongly increase your relative risk of using it. Whereas for other types of linguistic innovations, that's not the case. These phonetic innovations are spelling changes that reflect the way words are pronounced. So trying to spell a word in a way that seems maybe more phonologically direct. And that seems to be a thing where multiple exposures really increases your likelihood of using it, whereas these so-called, what I'm calling lexical innovations, these are just like new words that are not like sort of alternative spellings of other words. That's a sort of flatter line. So you get the single exposure, now you know about it, either you're going to adopt it or you're not. And so you can try to think about what might be different between these phonologically inspired spellings and these other sorts of linguistic innovations. I think about it in the sense of when you spell things differently, like that can just be perceived as an error. So it's sort of a riskier move to spell something differently, and you want to maybe make sure that this is something that's actually being adopted by lots of people before you just go and do it, or you look ignorant. But that's maybe reading too much into this data. But I think it's a question you can start to ask. Why does this sort of difference emerge? You can also estimate like a more complex kind of model. So a Hawkes process is a model for thinking about cascades of events and times, and thinking about essentially estimating parameters that parameterize the extent to which one event makes another event more likely or not. We do this, actually you can see sort of all the different linguistic features that we have here. This is what I'm showing. On the x-axis are just the counts of those features in our data. And on the y-axis, I do sort of this model comparison framework. So I can fit these are probabilistic models, these Hawkes processes. I can fit them to data and get a log likelihood. I can compare two models by comparing the log likelihoods of those models. And then I can have some base threshold, below which it's not a statistically significant improvement. And so, for example, if I add a predictive feature about tie strength, so I have some feature that says, person J used this word and they're a close friend of person I. Does that make them more influential? For several of the words, that really does seem to be the case. So you get you get a significantly stronger fit or better fit by incorporating tie strength as a feature. We also thought about geographical locality as a feature, but that really didn't work out in that case. So in the overwhelming majority of cases, that wasn't a significant improvement. Okay, so I want to talk a little bit about sort of annotation problems because most of what I've showed you, maybe it seemed like you could do in a completely automated way. I just get the Twitter data, I apply some kind of statistical analysis, and see how the results shake out. But in fact, actually in several of those projects, there was at least some kind of manual filtering, and that's what I want to talk about in the last, I guess, 5 minutes. So we have some really recent research, actually we just submitted on innovations that actually don't succeed. So the picture I've been painting so far is about language change as sort of successful innovations, but most innovations, of course, in the end fail in the sense of they're just not used anymore. So these are 2 examples. I don't remember what this abbreviation stands for on the bottom. I guess this is one of those phonetically inspired spellings on top. And so these are cases, this is now Reddit data. And so these are cases where the frequency was increasing for a while and then started to decrease. And so we wanted to ask, what are sort of the characteristics of innovations that are more successful? And in particular, this is a question that's been asked before on a social dimension, but linguistic innovations, we want to argue, are not the same as other kinds of social innovations that you might spread through online media. So you can think about a hashtag or a URL and how does that propagate through a social network. Linguistic innovations are a little bit different because they have to be integrated within a linguistic system. So you have some innovative word or something, but that has to that's actually going to be used in a sentence that's going to be interpreted linguistically by the reader. And so that perhaps exercises another sort of constraint on how language change happens. So what we had to do then is to find innovations that were successful and innovations that failed. And so essentially we designed sort of conceptual models of what we thought success and failure would look like in terms of frequency counts over time. We found words that were sort of close fits to each of those models. So the top one is sort of successful. These 2 are 2 different sort of failure models. And then when we looked at the terms that fit each of these models, some were sort of things that we would really think about as linguistic innovations. But others were really like names that might have been relevant, very relevant at one point in time, but then became less relevant. That's not really a linguistic innovation that we're talking about, like our presidential candidates in the U.S. in 2 different ways, or just talking about the year 2017. So we just sort of wanted to basically manually filter this out. And I guess my point here is that when we think about annotation, you could say like, oh, you're looking at tens of millions of documents. Like, how could you possibly annotate that? But this is type level annotation, right? So tens of millions of documents, way too many words to annotate. But if I build a dictionary of those words, and if I specifically focus on words that fit some kind of statistical framework that I think sort of explains my phenomenon, that annotation task I think is much more tractable. So to annotate hundreds or thousands of these individual words, that's a couple of days. I'm going to, because I think I am short on time, I'm sort of not going to tell you the results of that one. I want to talk about a similar sort of annotation in a kind of higher stakes setting. So, so a persistent problem in online social media is hate speech. What seems to be the case are there are these forums that act almost as echo chambers for hate speech, where people go, maybe they had the interest in going to this forum, so they already had some motivation, but then the forum really became a place where hate speech was used really with high frequency. And so Reddit, this was sort of a persistent problem on Reddit. And in 2015, they had really gotten a lot of negative publicity about this. And so they closed several forums. And they have an anti-harassment policy, and that was the basis that they used to close these forums. The 2 that we're going to look at, this is essentially a racist forum in the US, and this is a forum dedicated to hating fat people. I'm going to show you text from both of these forums in a minute. The stuff I'm going to show you is not good, but not the worst, but fair warning, I guess. So the first one is, this is from the racist forum. And this is fairly characteristic of stuff that you can see there. And this is from the anti-fat forum. So the sort of research question here, I guess I should have said on the previous slide, is like, what is the effect of eliminating forums like this? So there's an argument to be made that like these forums actually play a valuable role because they get all these hateful people into one place where like no one else has to deal with them, right? And so maybe by eliminating the forum, like the people will just go to other parts of Reddit and spread their hate speech everywhere else. And so maybe it would be better to just allow them to like congregate in these sort of little corners of Reddit that you never have to go to. And so that's the question. You can sort of, in a sort of quasi-natural experiment, because Reddit closed the forums, we can then see like what happened as a result of that. They definitely did not close every hate speech forum on Reddit. So you can definitely still see hate speech on Reddit if you want to. So this paper came out a week or two ago, and it turns out like this political decision that Reddit made to close these forums was a very controversial one on Reddit. And so the research article that we had about this actually became the #1 story on Reddit about a week ago. And I found this out because my brother texted me and he said, well, your research is #1 on Reddit, and by the way, apparently you are the real Nazi. So, so that was his sort of summary of Reddit's response. I think it's not like totally fair. Like there were a lot of different responses on Reddit to the research, but there was definitely, I think, a lot of skepticism, especially about our ability to quantify what exactly counts as hate speech. So as this guy says, what exactly qualifies for hate speech, and my co-author sort of tried to describe the process here. And then some follow-up, well, how do you know this was ideologically neutral and not just a reflection of your political sensitivities of the person doing the filtering? How did you differentiate between people using hate speech and people talking about hate speech? That's actually a pretty, I don't have a great answer for that question. And more to the point, who choose these words? So I did, right? So this was a paper with many authors, but the hate speech identification as the NLP person on the paper, that was my job. So I will tell you what exactly qualifies for hate speech. So the thing that we did to get started was actually the same method that I used at the beginning of the talk to identify words that are characteristic of different, like 2 more slides, sorry. Words that are characteristic of different metropolitan areas. So the same sort of statistical method, but now I'm going to look at words that are characteristic of these forums. Is that fair? These forums were closed by Reddit for using hate speech, so therefore we take them as representatives of hate speech. Certainly not like a complete representation of hate speech. There are lots of kinds of hate speech that were not present in these forums. But again, from looking at examples, I think definitely representative of at least a fraction of hate speech. So we find just the top 100 words according to the statistical method, and then we go manually and we try to remove words that are, the way that I put it in the instructions was not intrinsically linked to racist or anti-fat discourse. And so I did the annotation and a student did the annotation. What happens is a lot of the words are just references to the forum itself or an abbreviation for the name of the forum. So fat people hate, FPH. People will talk about the act of posting offensive content. I didn't consider that hate speech in itself. That's maybe talking about hate speech as opposed to using hate speech. So we didn't include this. And then we had a set of words that were frequently used in hate speech, but were also could easily be used in a non-hate speech context. So like on the racist subreddit, like people like to talk about IQ a lot, but like that doesn't, maybe that makes IQ an inherently racist term. That's maybe a more radical critique, but we didn't want to go that far in this analysis, so we filtered that out. And so in the end, we filtered out about 80% of the original words, but the 20% that were left, we felt like really pretty confident about characterizing as hate speech. And the agreement between the student and I was quite high. Just to be safe, though, in the paper, and this is the response that we could offer to these commenters on Reddit, we just post the results with both the manual annotation in terms of filtering out these words that we didn't really consider to be hate speech, and just the complete list to say, if you really don't trust me about the filtering, like this is just what came out of the algorithm, and you can look at that as well. We compare the treatment subreddits, so this is sort of a causal inference kind of way of talking about what we're doing, but like getting your subreddit banned is the treatment, and then we compare the frequency in posting hate speech of the users that typically posted in those subreddits. Of course, once the subreddits are closed, there's no more content there, but the users can go on and post other places. And then we have a control. We have people that posted in very similar subreddits to people that are in the treatment, but they didn't post in the subreddits that got banned for hate speech. So there are other subreddits that are frequently used by people who post in these hate speech subreddits. We look at people who post in those other subreddits, but not the ones that got banned. That's the control. And so you can see, the banning the subreddits had a really kind of massive effect on the amount of hate speech that people used. These people that were in the treatment, that were frequently posting in these hate speech subreddits, their rate of hate speech went down dramatically, and the rate of hate speech of everyone else stayed basically flat over the weeks of the study. Okay, so that's sort of the overview of what I talked about. I guess I had 2 summary slides, which I can go through pretty quick because I am out of time. I think rare events like lexical variables have a lot to teach us about sociolinguistics. They haven't been used much in sociolinguistics, and I think they require methods that are quite different from the sort of more traditional sociolinguistic variables that people think about. I think big data makes it easier to ask maybe questions that I have uncharitably characterized as lazy questions about big social categories. I think, but it also enables more fine-grained and subtle kinds of questions as well. And I think the sort of longitudinal data, I think I should have said we were looking at maybe 3 years of data on Twitter. This Reddit study was also about 3 years of data. I think it can offer kind of a really different perspective on language changes in progress, looking at data changes in real time. But automated analysis needs to be paired with manual filtering as well. To close to some questions, I think any kind of automation implies errors, and not all errors are the same, right? So there's no way that we built a model that captures anywhere near even 50% of what people would consider hate speech. If the stuff that you're missing is missing at random, that's probably okay. You have big N, missing at random, not a big deal. If the stuff that you miss is, a more systematic category, then that is a bigger problem, right? So this sort of orthographic way of indicating who's Jewish. So this is a thing that became popular on the internet in the last year or two. We don't really have a way of capturing this because we're thinking about words. Our analysis is on the level of words, and we're not going to capture, I think, the sort of orthography. So big things that we can miss like this. No matter how big your N is, if you're sort of systematically biased to miss something like this, then you're potentially missing something important. So I think as a field we need to think about making our methodologies for identifying this kind of bias and correcting it more rigorous, and that's something I'd like to continue to think about today. Okay, so thanks for listening, and thanks to my co-authors and sponsors.